Me acute de la D.
Okay, let's get started. So, good afternoon, everybody. Thank you for joining. My name is Philip Howard. I'm a senior consultant with Evenflow, and I'll be moderating the second of our series of Earth observation for urban issues. And in this case, we're going to be focusing on the mapping of urban areas. Just as a bit of an icebreaker, and also while we wait for a few final people to join, we do have a few questions that we'd like to do. If we could move to the first slide, please. So hopefully everybody knows how to use Mentimeter. The QR code is here. If you could scan that or go to menti.com and use the code that you see on the top there, 24879070. And we'd just like to understand a bit about our audience, whether you're working for cities, a service provider to cities, or coming from the Earth observation industry, or something else. So I will just give a minute or two for you to access that while we also wait for other people to join. So just to repeat that, so you can either scan the QR code here, or you can go to menti.com and use the code 24879070. And we also have the details in the chat for those of you who didn't catch that. So we'll just wait one moment for the first responses to come in. Okay, very slow, at least. Here we go now. Here we are. Okay, so we have quite a lot of cities represented here. We also have quite a lot of other, which means that possibly we didn't choose our categories very well, and that we need to rethink how we ask this question for the next series, because we shouldn't have quite so many others here. Maybe we'll contact people offline to find out who they are. So maybe let's leave that there and skip to the next slide. And again, just a very quick one, just to get an idea of the geographical spread. If you could just type in where you're joining from the country, just to get an idea of where we are getting people joining from. So, okay. So some interesting there. We're getting some core European ones I would have expected, but also some outside of Europe. That's very interesting distribution. Okay. Let's keep going because I'm afraid we do have a lot to get through today. So the very last question, so this is a more technical one and it's more aimed at the people responsible for cities, but are you a Covenant of Mayors signatory, supporter or coordinator? Okay, no, but at least with a small minority that is yes. Okay, that was nice just to break the ice, but also just to give a bit of time for the last few people to join. So let's move on. And this is our agenda for today. We'll give a very quick introduction. It will be very quick because we already gave one of this series and the introduction is the same and we don't want to bore you with repetition. We'll then move on to our keynote address about how space can be used for global monitoring of the built environment. I know a lot of people from the cities are interested in getting an overview of what tools are available to support this. So we will then have a quick presentation showing the overview of the tools. We'll then dive into 3 different case studies, one around Copernicus, but then 2 where we look at commercial solutions that can be deployed to complement what's being done in the public domain. And then finally, we will proceed to a panel discussion and a Q&A. One thing I would say is I really do encourage this to be a participatory webinar. Please put any questions that you have in the chat, ideally aimed at a particular speaker, but also feel free just to raise any general points, and then we'll bring them up at the end. With that, I will pass over to Alison DeLuise from the Covenant of Mayors, just to give a very quick introduction to the Covenant and to give some context to why this webinar series is happening. Alison.
Lovely. Thank you, Phil. Well, firstly, very well welcome also on behalf of the EU Covenant of Mayors, and we're pleased to have you join us, whether you participated in the webinar a month ago or whether it's the first time today. But for those that did listen last time, sorry for this slight repetition of the introduction. But I did want to just mention what the Covenant of Mayors is. So my name's Alison DeLuise, and I'm leading the Covenant's new work stream related to space-based services, which I'll explain in a moment. The Covenant of Mayors is a EU Commission initiative. It's been around for 15 years, and really its aim is to support local authorities across Europe to achieve their 2050 visions of decarbonised and resilient cities with access to affordable, secure and sustainable energy. So we have over 11,000 local authorities. I see that there's a few people from Greece on the line. Maybe 1 or 2 of you are signatories. It covers all 27 member states. And basically the municipalities make a political commitment to achieve their visions. And then they back this up by development of what we call sustainable energy and climate action plans. And those action plans have activities around 3 main pillars. So mitigation, adaptation, and energy poverty. So Duke, if we can change slides. So just to mention that we began exploring this topic on space-based services about 18 months ago, and we've developed this great relationship with the European Space Agency and through them the SEF, so Phil and his team, but also with USPA and other EO-focused initiatives. And we were talking with our signatories in our community, and they indicated that there was really a strong interest in seeing how these services could provide all of these different insights into the different stages of this framework that you can kind of see here on the slide. But we also heard that it's quite difficult. They don't necessarily know what services exist, how to access them. So there's quite a lot of hurdles to overcome to ensure that the use of Earth observation services and data can actually support them in their planning, their inventories, their risk assessments and the such. So basically that's where we're at. We're working with SEF and other partners to really start to bring some of these tools and services and information to our signatories. So we're in exploratory mode. We're learning as much as our signatories are. So we encourage you to continue this journey with us. Reach out to ourselves or SEF if you have any questions after this, and we'll see how we can support you. So with that, I'm going to hand back to Phil and wish all of our speakers much luck in the presentations.
Okay, likewise, I won't take much of your time, but I should say who we are because we've said SEF several times. Who is SEF? We're the stakeholder engagement facility supporting the European Space Agency. Our role is to make potential users aware of space-based solutions that might benefit them and to provide them with practical support to get started. What that support is really depends on what their needs is. It could be webinars like this one, it could be making connections, putting you in touch with people, it could be organising training courses or providing direct support. Really, it's for you, the target community, to tell us what you think you need. Now, this webinar is the first step in that process, making you aware of what's out there, giving you an idea of what there is, but we really hope that this will not stop here. So go to the next slide. You can see the sort of challenges and solutions that we tend to address. We're starting with awareness, where people aren't aware of what the solutions are, or they vaguely know that they exist, but they don't know how they can meet the needs. And for that, we do showcasing, presenting things like this. But then we move to the next level, the acceptance, where people know that the solutions exist, but they need help in getting started. And again, we can provide guidance, support, connections, case studies. But then finally, when you really get to that next level of adoption, you need technical support, but you also need support in some of the non-technical things, demonstrating value for money, demonstrating that you are gathering data in a way that meets your obligations, convincing your management. And that is also things that we can support. Really, we want to use this as the first step as a dialogue to understand what your problems are and where we can best support you. If we move very quickly to there. So this is about today's webinar. The aim of this webinar series is to showcase the range of Earth observation solutions, but I really want to emphasize this again. The more feedback we get, the better we can focus our future efforts to support you. Please do give us feedback during the webinar. You can raise a question in the chat, or we can put you, we can open up your camera and mic later in the Q&A section if you want to raise a point directly. But if you don't want to raise something in the webinar, that's fine. Please feel free to contact us directly. We will leave the details at the end. With that, I think that is all from me. I'm going to turn over to our first speaker, Thomas Esch. Thomas is working for DLR, the German Airspace Centre, where he's a senior scientist, group leader and project manager at the Earth Observation section. And he's also an honorary professor at the Stuttgart University of Applied Sciences. So Thomas, over to you.
Thank you very much for this kind introduction. And also, it's a great pleasure for me to now give you a brief introduction to the Earth observation and show you some examples what one can do with it. So what you see here already running in the background is actually real-time animation of really existing satellite systems that orbit our Earth. And what is quite interesting to see is it's quite a mess. So it's about mass, let's say, of systems, so about more than 11,000 at the moment. And what we are mostly working with is are the ones that are orbiting in a polar orbiting path, but where the Earth is moving along or underneath the satellites, and where we can collect time after time, strip after strip of the Earth's surface. And our working horse here are the Sentinel satellites, which you can see on the left-hand side now. So it's a Sentinel-1 down to Sentinel-5P and also Sentinel-6 in the future. And the point is here that this data or these sensors allow us to collect about 16 terabytes of data every day at the moment. So just for you to let you know, one Harry Potter book, if you would translate it or put it directly into text online or digital, it would mean that it's about 2 million times the amount of the book. So we would have 2 million times the Harry Potter book that's collected per day in terms of satellite imagery. Of course, we also use other systems, for instance, Landsat. It's a US satellite system that allows us to collect or go back in time, let's say up to the mid of the 70s or beginning of the 80s, so a bit longer time series. And also we have different other missions, for instance, here as an example, TerraSAR and Tandem, which is a German satellite, a SAR satellite mission that allows us to collect data also for specific purposes. So again, for those who are not really into Earth observation, I want to show you once again or briefly how this data looks like. So here we have an RGB representation of a Sentinel-2 multispectral scene. And as you can see here, we have nominally per pixel resolution of 10 meters. So with that, it's clear if you look at the lower left hand side that if you have a village, for instance, you can recognize roughly where there are single houses, but it's not a high enough resolution that would allow us to really go into detail and identify or delineate single houses or also single cars or smaller scale structures. On the other hand, of course, what is the big advantage of these kind of data sets that we get every few days a new scene all along the Earth. So we can really set up a constant, temporally constant monitoring, though not having the highest precision that are, for instance, delivered by commercial systems where you have to pay for. So here it's all open free data that we can make use of. And apart, of course, from the temporal domain, we can also use spectral information. So there are even more bands, so electromagnetic wavelengths where we collect data. And this is kind of a spectral fingerprint that we can use to identify different objects or land cover types. And I will show you soon how this works. Complementary, just to give you another example, Sentinel-1, for instance, is a radar satellite. So it's an active system that collects data. And the big advantage with these active systems is that they can even look through clouds or also collect data during night. So we do not depend, like with the optical systems, on daylight or sunlight. And also radar systems, since they are active, they have a little bit of a different, let's say, characteristics, which are often complementary to optical data, so that we can, by using, for instance, both systems, get even more precise descriptions of the surfaces that we are looking at. So now we come to the, let's say, more technical part on how we analyze these data sets. So basically, I would say in most of the Earth observation applications nowadays, the idea is to come from the left-hand side of the slide to the right-hand side. So on the left-hand side, we have the, let's say, we call it big Earth data. So of course, in our case, centered around Earth observation, satellite data that I showed you, but also including lots of other sources, such as population statistics, volunteer geographical information, local surveying data, and so on. We put all this together, and this can easily be, if you work large scale, terabytes or even petabytes of data. So one of the key, of course, challenges is now to organize this data and effectively analyze it, because as I said, finally, we want to come to the right-hand side. So to a specific user, for instance, a specific application that we want to support. So we want to turn this mass of data into actionable information. And for this, we have to compress it somehow. We have to systematically analyze it and then analyze it and give you one dedicated information. What this means, I want to show you in the next slide. So here you see again an optical satellite image of the southern German area, where here we have Munich on the right-hand side. Here we have the bigger lakes, Lake Starnberg and Ammersee and so on. So now, of course, as a non-expert, it might be difficult for you to extract certain information. So what I show you now is we trained an algorithm, so a machine learning method that extracts automatically from the satellite image all built-up areas. And this is now shown here. So from the left hand to the right hand side, there's now the algorithm running through the image and highlighting us in black color wherever there is a settlement or build-up area, and all other land cover types are here shown in white. So this already gives a nice indication that if you are now interested in analyzing settlement patterns, this is a much more useful, valuable, and handy way for you, let's say, to work with it if you are interested in settlements or settlement patterns, for instance. At the same time, coming back to the first slide or slide before that I showed, here we just have, a very small volume of the data set behind it, simply a binary mask, whereas the original satellite image might be 100 times the data volume. And this, of course, would also make it easier for users to work with this kind of data. And at DLR, we have one, let's say, working horse on our side where we try to support as many applications as we can with open and free data. And this working horse or initiative is the World Settlement Footprint, or WSF in the abbreviation. And it's all based on the analysis of open and free satellite data, mostly Sentinel-1 and Sentinel-2. If you go back in time, we also take into consideration Landsat that I briefly introduced before. So far, we have 3 data sets that can be downloaded open and free. It's the WSF, which are these binary masks that I already showed you. We have the WSF Evolution, which goes back in time for about 30 years, so from 1985 to 2015, and currently we are even continuing it to 2025. And then we have the WSF 3D, which gives you an indication of the 3D structures of the building heights within the build-up areas. How this looks in detail, I can show you now. So here you see an example of the WSF 2019. So that's the global map of 10-meter resolution of the build-up area versus non-build-up. And the build-up area, as I showed before, is shown in black, and the non-build-up, all other land cover types are shown in white. Also, here it's important to note that our algorithm identifies build-up only there where there is a vertical structure, so a building or something like deck construction. So no streets are shown, also runways of airports. And that's why you get a very nice impression, as you can see here and here, of the real build-up structures in the buildings. Again, considering the 10-meter resolution, we are not able to extract or delineate single buildings, but it gives you anyway a very precise idea globally where buildings are and how they are distributed. Then one example or one application that we had in the past, we produced these kind of binary maps for years, and more users actually worked with it, but they still said, okay, we have sometimes challenges or face challenges in terms of For instance, we want to use it to decide, is it a more rural settlement area, or is it more an urban settlement area? So we need further tools. And this is also something that we support. So what I show you now is a method that we developed where we kind of created an artificial, I would say, network or spatial network, a spatial graph. So we take this binary data set, so this binary map, convert all congested areas. For instance, here you see it's a cluster of black buildings in simple words, and we form or transfer this with a segmentation into one object. This is shown here. So we have one settlement as one object, and then around the outlines of each object, we can look into a vicinity, for instance, 5 kilometers or 2 kilometers, and say, mark wherever there's another settlement in my 2-kilometer buffer and connect it. And then by doing this for settlement per settlement, we can build a spatial network that then allows us, a bit like in social media when you do analysis of betweenness, centrality, how important you are, we can also query the spatial network, for instance, in order to find out how central you are. And here we have an example of such a network. It's again the south of Germany. So here we have Munich, we have Ulm, here we have Stuttgart. And so these are the more urban clusters and congestions. And what you see with this connected network, that all these clusters have a red color. And red color in this terms means it's central, which was defined as this is a settlement patch or cluster, which is really big. So the area of the settlement is big, and the next neighbors are very close to my settlement. So this is, of course, typical for an urban area, whereas here you see it's a very thin density of lines, very black or black color, which means it's a very low centrality. And that is typical here in this case for the Black Forest, or it's representing the Black Forest. And this is typical for a rural settlement pattern where you have very small, let's say, settlement patches, and they are very far away from each other. So with these kinds of tools, you have then a very good instrument to also quantitatively, with objective rules, analyze patterns and connections. And we use this, for instance, but how you can see here in the next example, to identify automatically different hierarchies of settlements. So this is in the Punjab area, so it's in the border region of India and Pakistan, where we automatically extract 5 levels of settlements. So the red ones would be the most central ones, and then we go via the orange ones to the yellow ones and the bluish, which might actually not be really visible here, which are the very small ones. And it's interesting to see that they all kind of follow a certain pattern. And of course, with our method, we can then describe for each settlement what the relations to your neighbors are. And this was used, for instance, by a company for off-grid electricity planning, since we can give you for each object how many neighbors are, for instance, or neighboring villages are within a certain vicinity. And this might mean, for instance, for you as a company, that you might, if you have a lot of connections within a few kilometers, you can connect with, for instance, a power line or water, sewage or whatever, many settlements. And we can give you this information based on Earth observation for large areas, even within days. And that's the goal of our methods, so to give you large scale maps and information on a certain topic. Another example here now shown is the WSF evolution. So these are the binary maps that I showed you, but this time based on Landsat. So here we have a spatial resolution of 30 meters. But the nice thing is that Landsat connected with actually a comparable quality, this kind of images from on the early 80s, and with a constant quality, let's say from 1985. And we here derive with our algorithms per year from 1985 up to 2015, every year, let's say the settlement extent. And with this here on the example of Cairo, you can really literally see the cities growing, so how they expanded. Again, on the lower left here, you see it's a total data volume that we analyzed of 7 petabyte. Just to give you an indication, I mean, it's 7 petabytes, around 25 years of nonstop full HD video. So it's really a massive amount of data that we could analyze here in order to give you, let's say, a trend of or an overview of the global settlement development over the last 3 decades. Of course, what was animated, you can also show it in kind of a static view, as it's shown here. So red would mean you have all those build-up areas that had already been there in 1985, and then via the different colors, it moves on to the current state. And of course, you can do this globally, as I said. Then if you have more blocky color scheme or distribution of colors as here in Amsterdam, it would mean it's more an indication of a planned development. Whereas if you have this more organic color distribution in the spatial domain, it means this is usually more an unplanned development. And of course, the nice thing is, and that's the goal, as I said, that we can combine it with other information. And here you see an example where we supported the development goal 1131. So what we did is we had or plotted our settlement cumulative growth that we derived from the WSF evolution with statistics on the population development over the last years. And of course, with that, you can clearly see if a country is more sustainable in terms of this indicator would mean that your settlement growth is lower than your population growth, or you can see if you're more sustainable. And again, this is a nice indication of how you can make use of this data. And finally, before I conclude, we can see that, of course, we also have different techniques, for instance, digital elevation models that allow us to even give you not just a binary representation of the settlement surface, but also describe the settlement height, so the building heights. We can put this in correlation, or let's say combine it with building footprint information to really get a per building estimation of the height. It's not super precise, as you might know from LiDAR, but it's something that we can at least provide you at the global scale. And with that, again, it's another example. It allows us to really come up with area-wide information for arbitrary areas. So here on the left-hand side in this example, you see you can estimate the distribution of the building heights per country, per city, or whatever spatial unit that you are interested in. And then, of course, we can even go down to the very local scale. This example, Paris, where we can generate different circles around the city center and then define and quantify what's the building volume or the building height in the sector. And this allows us, for instance, to describe if there's a polycentric or monocentric city, or also put it in relation on the lower left with economic data, where one can, for instance, see that usually the more rich or the richer a country or a city is, the higher are the building heights in the center, and the higher is the ratio to the lower outskirts. So with that, I'm ready and I'm done, and I hope you liked it. Of course, I know it was a rush through the topics, and just to let you know, finally, also we are continuing our World Settlement Footprint Suite, so there's a next generation of open free data that will soon be available to you. Thank you very much for your attention.
Thank you, Thomas. That was actually rather fascinating. I see you've got put your contact details there. We will come back to Thomas later to ask questions. So if anybody does have questions, please do put it in the chat. Just before we move on, we would just like maybe a bit of clarification, because we call this urban mapping, but of course there's lots of urban mapping. There's buildings, there's trees, there's roads. Maybe just a quick question to you. What exactly are you looking for in a landscape mapping service? You can either follow the QR code there, or you can join at menti.com and use the code that's written there, 24879070. Resolution I see here, this is not just thematic, but looking there, planning support, time series, yes, all valid points. I mean, there's different things you can measure, but there's also different things you can use it for. Green spaces, yes, buildings, trees. I know green spaces is something we'll come back to, tree canopy. Light pollution is an interesting one. Okay, that's very interesting responses. I'll come back to those. Feel free to keep inputting this. We are going to pick this up later. In the meantime, I'm going to quickly pass over to my colleague Diego Carcedo from SERCO, and he's also from the ESA SEF team. One of the things we've been asked is to provide a catalogue of available services that meet these needs. So Diego will quickly present what we've been collecting. Diego.
Welcome, everybody. It's a pleasure to be participating in this webinar. Thanks, everybody, for your attention. So today we will explore a range of geospatial tools designated for mapping urban landscapes. These tools, both for public and private, provide critical insight for urban planning, environmental monitoring, and infrastructure management. First, we will start by looking at the public sector tools available for urban mapping. So as you can see, we have assembled within SEF a product to outreach and for everybody that needs. It's a catalog of the different service tools and datasets that are out there available for everybody to use. What we are seeing is the ones that are publicly available. There's the essential data sets for urban mapping and monitoring. As you can see, there's also the DLR, as was mentioned recently by Thomas, the World Settlement Footprints that offers high resolution global urban data, and also the Copernicus Urban Atlas, which will be presented in the next presentations. While the Copernicus Urban Atlas provides detailed land cover maps for European cities, we can also find other urban covers for the different parts of the world. There are also additional resources like the CLMS and the Urban TEP, which are able to support green spaces monitoring, alongside with another global datasets as the NASA and GRC that enable large-scale urban analysis. These tools help policymakers and researchers to make decisions for sustainable urban development. In the other hand, we have also assembled a catalog of private services, some of which will also be presented today. These tools complement the public datasets and are offering also advanced analytics, real-time monitoring, and AI-driven insights. There are different companies out there, like the Tree Economics, Safe Space for Environment, that mainly focus on urban greening. There are others like Terra Monitor and GBIL that provide satellite-based change detection. There are those who are more focused in infrastructure and energy management. There's also like the platform from EGEOS and OHB. There's also some that are mainly using AI, complementing with remote sensing to monitor different assets, as the Mind Earth, who is going to be also presented today. In summary, the different solutions enhance urban planning and the resilience and sustainability by leveraging cutting-edge geospatial technology. This slide is not meant to be readable, but it's a slide presentation of what we have been developed inside SEF. So please reach us and we can provide you this tool, and the one that we also did for the first webinar. And this also live, and we like to think that it's an evolving tool. So please also come and provide your feedbacks if you think your services or your tools are not yet being taken into account. And thanks for your time.
Okay, thank you, Diego. So I'm now going to pass over to Anna Sousa from the European Environment Agency to talk about the Copernicus Land Service and in particular some of the tools that it has for urban areas. Anna is a staff member of the EEA, which is responsible for the Copernicus Land Service, and she is responsible for some of the key products which have urban relevance. So Anna, over to you.
No. Yes. Can you hear me now?
Yes.
Oh, yes, we can. Yes, we can.
Okay, good. Thank you. There's always these hiccups. They always show up. That's my picture, but that's from a few years ago. Thank you for introduction. Very pleased to be here representing the European Environment Agency. We are the entrusted entity for the implementation of the Copernicus Land Monitoring Service. So our service offers numerous data sets. They are all extracted from satellite imagery with support in situ data as well. And of course, they range from biogeophysical parameters to uncover land use information, to ground motion, and to reference data. What I will try to do in the next few minutes is to highlight some of the products within our portfolio that may be relevant to cities. And I will finish by showing some use cases that are available in our website under the Use Cases tab for anyone to read. And they were built up putting together some of the data sets within the portfolio. So I will start with one of the most prominent products already referred today, I heard. In our portfolio called Urban Atlas. It's a family of products. It offers detailed land cover land use information and a minimum mapping unit of a quarter of an hectare. We have a time series that started back in 2006. It has been updated every 6 years, and we also offer change map between the periods, the reference years. Additionally, we also offer building block height measurements and an additional layer with street trees. The dataset currently covers 788 functional urban areas across Europe, and from 2018 onwards, we will gonna shrink the update period to 3 years because we are trying to respond to user requirements for more frequent updates. This is something we hear a lot. Now, this is an example of how the land cover product looks like. On the right side, you can see the extent. So the functional urban areas, of course, it doesn't cover all smaller urban areas outside the functional urban areas, but this is what we have. On the left side, you can see an example of the geometric and thematic detail of the product. This is a harmonized product across Europe in terms of specifications and also in terms of quality, so we can use it to compare across Europe. And we also are offering a long time series. We are now working in 2021 update, and we will continue with the 2024. In this current update cycle that we are engaged now, we have introduced some technical advancements aiming at more automation of the change mapping activity. So we are making use of Sentinel time series, Sentinel-2 time series to devise heat maps highlighting change candidate polygons, and together with very high resolution satellite imagery, we delineate with a significant level of precision those change polygons. And why am I stressing the change? Because this is what we are interested in, to changes over time, not so much the status, but the changes, what happened in the landscape. Even though still in production, I can show you some examples of changes between 2018 and 2021. And here you can see a new construction site along a road on a forest area close to Stockholm. And we expect, or I expect, that in 2024, the construction site will turn into an urban fabric or maybe something else. Now, another example, this is Amsterdam. You can see illustration with a construction site over a water surface. And this will become a port area, and maybe it's also a coastal protection work ongoing. Now, one other product within the Urban Atlas family is the building block height. You already heard about similar products from previous presentation. Ours is composed of a regular grid of 10 by 10 meters containing the height information of the cells. We produced it for 2012, and we are now updating it to 2021. And of course, it will also be updated for 2024. Now, another layer that was also mentioned before, I see in the table, which is maps at 10-meter resolution, so the resolution of Sentinel-2. It maps the imperviousness of the soil measured in percentage from 0 to 100. So it offers, as you can see below, it offers a dense time series since 2006, and that has been updated every 3 years. And one derived data set from this one is what we call the impervious built-up layer, where entities such as roads and parking lots and others have been removed, so only keeping the built-up component. And on the right side, you can see an example of a change between 18 and 21. In red, there's an example of new ceiling, so more buildings popping up. But there's also in green, there's an example of a decreased ceiling because some buildings were removed. And we are using this to report on the soil ceiling index under SDG 11. Now, just one very quick slide to show the evolution of soil ceiling. This is Stockholm, 2006 to 2021. And from the colors of the pictures, you can see there's a bit more densification than just expansion over the city boundaries. Now, one more very interesting new product in our portfolio called the ground motion. It detects and measures the movement on the ground across Europe with millimetric precision. It's extracted from Sentinel-1, so the SAR data. And is currently composed of 13 billion measurement points. It is updated annually and it can be used for many applications. We hope that city authorities can use it to monitor the structural integrity of bridges, of railways, and of course buildings, so that urban planners can make data-driven decisions about where to build a new infrastructure. With this next slide, I want to, this one and the next one, I want to show two CLMS datasets that are being proposed as baseline for monitoring two indicators under the Nature Restoration Regulation, Article 8, dealing with the urban ecosystems monitoring. So this one is the reference, the one I'm showing is the reference data set proposed to identify the baseline and for monitoring the urban green spaces indicator. It's called CLC Plus Backbone. It's a high resolution land cover data set at 10 meters, featuring 11 basic land cover classes. And it's updated every second year since 2018. And this is the reference data set proposed to identify the baseline and also monitoring of urban tree canopy cover that I already see mentioned. This indicator, it's called tree cover density, a high resolution layer within the portfolio, a 10-meter resolution. It's available since 2012 and from 2018, updated annually. So it's a good frequency. Now I'm reaching the end of the presentation, but since I'm included here in a use case slot, I want to show an example of a use case where we have put together several CLMS data sets. Those are imperviousness, tree cover density, dominant leaf type, grassland, urban atlas, building height, and land use layer of OpenStreetMap. And we derived what we call a local climate zones data set using a known methodology. It's what we call standardization of rural and urban landscapes that have similar thermal characteristics. We did it for 2012. We are doing it for 21 because we are interested to see the changes. And we hope this kind of information to help city planners identify which areas of the city and which groups of the population are most at risk, and eventually help target it, mitigation actions and develop heat wave response plans and mitigation strategies. Now I finish by leaving you with a collection of use cases addressing cities, and they are published in our website. One about management urban green spaces, one to devising a method to combat urban heat island effect, how urban heat island affects tree seasonality, and the heat wave risk modeling with Urban Atlas. And also a report from the GRC about access to green urban areas. So I hope you find this collection of data useful for your work. Thank you very much.
Thank you very much, Anna. For anybody who's rushing to get all of these QR codes, please don't worry. We will be sharing the slides afterwards, so you will be able to look at this at your leisure. So thank you again, Anna. Now we're going to turn from the public products to some of the private products. We have two case studies here, and maybe this is thing we can come back to in the panel discussion, is the pros and cons of the public versus private. But let's go into our examples. The first example is from Envirosense in Hungary, and I'd like to introduce Gergely Hunyadi, I hope I pronounced that correct, who is the head of department for tenders and projects within Envirosense, with more than 15 years experience in using remote sensing and GIS, and he will present the decision support tool. So please.
Thank you very much. Good afternoon, everyone. Really glad that I'm being here. So I would like to, first of all, just present our company, Envirosense Hungary, which is located in Hungary, in Debrecen, close to the Romanian border. As it was mentioned, the company was established more than 15 years now, since 2009. And it's a spin-off company of the University of Debrecen, which is located also in the same city. We are an SME, we're around 40 people, or the number of 4 employees, and we can also connect 30 experts. And our main businesses are remote sensing, also aerial remote sensing. We have our own sensors as well, but we also deal with Earth observation data and Copernicus data. And we are active in Hungary and in the EU markets, and we have some projects also outside Europe. And I brought you 3 case studies which were ordered by the municipality of Debrecen and 1 district of Budapest. And I try to be very practical and just show the results and the outputs, not the data processing methodology. So in case study 1, we had a problem that the decision makers would like to have information about the increase of built-in areas, and also wanted to have an overview about the change of peri-urban green areas and green corridors. And for them, we gave a solution by analyzing Sentinel and Landsat time series data. And we produced the map that is shown in this slide. With the orange color, you can see the built-in areas in which also were in 1991 at the area. And you can see the increase of the built-in areas with red until 2020. And as you can see, it's really great that the highways are shown very nicely on the picture. And also there is a red block over here at the top left at the map, which is the BMW factory, which just started working in 2025 in Debrecen. Also, on the other hand, we had an increase in the green areas, which was quite a good information. But however, the size of the green areas are increased. The number of the green corridors and the length of the green corridors decreased. So it was a very interesting result that we had after this analysis. The second case study was ordered by the municipality of District 13, Budapest, Hungary. It was in 2024, and they wanted to know information about the green areas of the city, because they wanted to start working to build a green cadastre and a tree cadastre. And for this, they wanted to have a map where land use categories can be seen, not just the green surfaces, but also other surfaces that can be classified. And the analysis that was done was based on multispectral planet, large resolution planet data, and also aerial LiDAR data. And as you can see in this short animation, we not just only gave them a map, but also gave a QGIS project file that can be opened by open source software solutions. Because in this case, we not just only wanted to give the results and the outputs and the data for our contractor, but also wanted to let them and show them how to use them. So not just only stopped at delivering the deliverables, but also continued with trainings and education of the users. And the second case study, it was also ordered by the municipality of Debrecen, and they were curious about the overbuilding of the residential properties and the residential lands, because the local regulatory plan says that in many areas, the maximum percentage of built-in areas cannot be larger than 30%. And they wanted to know which are the plots and which are the residential properties and lands that has overbuilding and larger than 30% of the built-in size. And as you can see in these 2 maps, on the left-hand side, it's the buildings identified in the land cadastre, which is the officially used and the data given by the national authorities. And with the right-hand side, the buildings are identified with the Earth observation data. And as you can see in the middle, there are many buildings that can be shown and can be identified by using Earth observation data, and they're not included in the cadastre. So we can start processes and then start the decision making by decision makers about the next steps. So, and about the conclusions regarding to these case studies and analysis, We think that Earth observation is a very great tool to support decision making, but data, however, it's very good and input for answering many problems. Itself, it's not a solution. So we have to think together, and common understanding of the problem is needed. And the gathered and interpreted information is the solution, not the data itself. So we should move forward to easy use tools and give information and give data products that can be understood and interpreted easily by end users as well. So I hope these few slides were interesting. Thank you for your attention. And if you have questions, you can ask after the session and also in email or on phone. Thank you.
Thank you. It was very interesting to see some very good practical examples there. So just a reminder, we have one last case study now, but then we will go into a panel discussion and Q&A. And I would really strongly encourage everybody to ask any questions that they have. So with that in mind, I turn to Matteo Marconcini from MindEarth. He's a partner at MindEarth since 2021 and also been a project manager and research scientist in the Smart Cities and Spatial Development team at DLR. And he's going to talk to us today about building energy efficiency estimation with artificial intelligence. So Matteo, please.
Yeah, thanks a lot, Philip, for the kind introduction, and good afternoon to all the audience. It's really a pleasure to be here presenting this work. And just to give you a brief outline about MindEarth. MindEarth is an applied net research company with a Swiss-Italian flag that has been founded in 2018. And mostly it operates in the field of remote sensing and location intelligence. And I think that the uniqueness of MindEarth is the capacity under the umbrella of really advanced artificial intelligence to integrate different sources of information that include, let's say, first-party in situ street-level information, together with Earth observation data, of course, and complemented by GNSS mobility data. So this, I think, it's really a unique feature, and I will show you in a bit a project where at least 3 of these components are exploited at their maximum. Let's consider one of the major challenges that we have in Europe, at least concerning the building stock specifically. Buildings are, let's say, at the moment estimated to be responsible for 40% of the total energy consumption that we have in Europe, and 36% of the greenhouse gas emissions is coming actually from the heating and the cooling. But what we also have to take into consideration that of all the buildings that are constructed in our continent, I would say the majority, 40% are pretty old. They've been built, say, more than 50 years ago. And the 3/4 of those are considered inefficient. If we think that, let's say, only 1% of buildings are renovated at each year, this should, let's say, ring a bell. And especially also considering that at least for the next 25 years, we still expect the 85 to 95% of these buildings still to be there. So especially in the view of what is the plan of the European Union in general, we need something that can support gathering more information, and especially really supporting about targeting renovations. And in this regard, when we talk about energy, of course, the reference are these energy performance certificates, where buildings are categorized A to G based on their expected efficiency, which are an important tool, but they are mostly available, let's say, only for buildings that are newly constructed, or when you have, let's say, to sub-rent the part of the building itself. So the availability is not comprehensive. And as we can see from this map, which is 10-year-old, but still it's more or less still actual, few are the countries, those marked in green, where these data are publicly available. Those marked in red means that there's no public access, and those in blue and white, it really depends on the region, or there are some limitations. So again, we missed, let's say, to support policy, the right information in the right place. And this is a funded project, this Building Energy Efficiency Estimation with Artificial Intelligence, short BAI. aims at supporting this, because the idea is really to assess the building energy performance and retrofitting by a novel approach where integrates Earth observation with in situ data, where in the end, by purely exploiting, say, top view and facade imagery, we can reliably estimate what is the energy class A to G. And in this regard, the project has few main stakeholders in 3 different countries. We have KAB, the biggest social housing real estate company in Denmark. We have Immobiliare.it Insights in Italy, which is the, let's say, analytic branch of the biggest real estate website portal in the country. And then we have different stakeholders in Austria, which include the city of Vienna, the city of Klagenfurt, and a company Obenauf, which is actually responsible for targeted renovations. And so the idea is schematically represented here. So we wanted to collect street level information, both in the RGB and in the thermal domain, complemented with the top view multispectral imagery, and in addition, some indices that might be derived, from morphology. And with a few information that we have for some buildings about their energy performance certificates, we want to extend that to the entire city. And just to give you a brief insight on the different components. So to collect RGB imagery, mind that a dedicated mobile application has been developed where mappers are deployed, and thanks to the, let's say, capacity of the current mobile phone cameras, they can acquire a picture in targeted locations of the different facades, which are then, let's say, as you will see in the next slides, automatically processed through AI chain. And some of those are empowered with fascinating new technology, which are these thermal portable sensors. A few years ago, they would have costed thousands of euros, that now are really affordable, and they can be integrated in a regular smartphone that they permit to take thermal pictures, where, as we can see in the bottom left examples, one can immediately at first sight realize the degree of coating of the, let's say, the different facades, or let's say if specific windows have been, let's say, renovated with more isolation than the other in a given building. And coming from the top view, of course, we have the Earth observation data that are coming to help. So on the one end, there are the RGB orthophotos, mostly collected, let's say, in spring, every 2 years. Nowadays, this is a type of data that is systematically available in the vast majority of EU countries, with spatial resolution that range from 7 centimeters to 20 centimeters. But also, luckily, we have very high resolution satellite imagery. And in this specific regard for this project, we leverage also the possibilities offered by ESA with the third-party mission that enable us to work with imagery between 30 and 50 centimeter resolution. And in addition to this, of course, coming to the building geometry, the part of the morphology, we leverage a very interesting data set. Maybe most of the people in the audience are already familiar with that. Which is a Bucco data set, and that, let's say, provide information about high data, type of data, and age. Since time is running, just to mention that in this specific case, in Denmark, we were particularly happy because let's say the EPCs were available openly for all the different buildings that we targeted. In Italy, this is more on the regional side, while in Austria we are still negotiating because they are somehow let's say, private. And just to say, also integrated some of the layers that have been previously mentioned by Thomas, because also the construction year is specifically important. So we leverage this WSF evolution, providing information, let's say, of the construction year from 1985 to 2015, and also this newly data set, the WSF tracker that targets the missing period from 2016 to 2025. And last but not least, also a new layer that targets also the temperature. And I'm really coming to the very end, just to give you an idea. So besides showing you a bit of here the structure, we extracted the specific feature from, let's say, the facades and specific features from the EO components, and we put everything together. And in the end, I mean, what we could see here is that by grouping for Copenhagen, for instance, the classes A, B, C, D, and E, F, G, we could obtain overall results that are extremely successful because they outperform what is available in the literature. In the case of the word in the discussion, I can give you more details. But let's say this is going even beyond what were our, let's say, initial estimations at very last, because of course some of the users said, okay, but we are not really interested directly in the APC classification. We are interested in other type of features. And that's exactly what we've been doing. So we have been implementing different models that, let's say, try to characterize the buildings and give a kind of identity card. So for instance, based on Earth observation data, automatically estimating the roof shape, the roof material, or for instance, the presence of the PV panels. And sorry if I was a bit longer, but yeah, this is it. Thanks a lot.
No problem. Actually, I think you did very well to cover all that in the time that we were allotted. So thank you very much. So we have a few minutes for a bit of a discussion here. Again, I really encourage anybody to put a question into the chat. But while we're waiting for that, I'm actually going to call upon Alison as the kind of representative of the user here, the end user, to give your thoughts and reactions maybe to what you've heard so far today.
Yeah, thank you. Well, again, thanks so much to the speakers. Again, overwhelmed by the number of services and the capacities for us to actually access information to help us in land use planning and mapping. But, you know, I was looking at some of the participants. So we've got Malmo and Ghent, Ritemno, Almada, I know Cyprus Energy Agency, Campania. So we've got a range of who are sort of members of our community. And if I'm them, I'm thinking, okay, amazing information, but where do I start? I've got this need, but which tool do I go to? How do I know which tool is going to sort of meet my needs best? I kind of need expertise and support to even get me on the first step. And Gergely made a point about in the Budapest case study. You know, obviously the data is important, but the data is actually not the value. It's how is that data transformed to be able to provide insights, information, but importantly, how are service providers also training, building capacity of our cities, the staff in our cities, to actually understand, use this sort of information. So it's more sort of an observation. It's really exciting, but I'm still sort of thinking about, okay, if I'm Almada, where do I go next on this? And so that's really my main observation. And I hope speaking on behalf of our signatories that I haven't overstepped, but I'm more interested in hearing from them than from myself. So I'll leave it there. Well, thank you.
I think, I mean, we would love to hear that feedback as well, but I think for our from the SEF point of view, I think really we can support this process. We're really looking to the community a little bit in order to have some guidance as to what you would like to see. And this is meant as a taster. It really is a teaser to understand where you could go.
And so with that, can I encourage our community, our members that are on the line, whether it's in this format here, whether it's an email afterwards to Phil and myself, please feed us back what you're looking for, because that's going to shape what we do next. Thank you.
Yeah. One thing I would like to pick up on, and this is a point, maybe I'll start with Gergely because he kind of brought it up. But I'd also like the other participants' views on this, is we have the public tools versus the private commercial offerings. And I'd like to understand a bit how we see the pros and cons of each one, because obviously the commercial ones are, how should I put it? They're commercial, so you have to pay for them. But on the other hand, you probably get what you want rather than something fairly free. So I would like to understand a bit where you see the pros and cons of public versus commercial solutions. Maybe I'll ask Gergely first, if you don't mind.
Okay, thanks. Thank you for the question. Yeah, about the pros of the commercial ones. Usually our process is sitting together with the leaders of the municipalities or the representatives and think together with them, and then they give us their exact problem for which they would like to have answers. And as we searching for the internet and looking for public solutions, not always we can find a solution for the exact problem. That's why we start to develop our own solutions and give an answer by using our solutions.
Okay, thank you. And maybe I'm going to call on Anna to give more of a perspective from the other side, because obviously the Copernicus Land Monitoring Service is there to meet certain policy needs and has it with the users. How would you see the interaction between CLMS and the users in order to make CLMS better meet their needs?
Yes, thank you. This is a recurrent question over and over again since I started work in the 90s, and we're not there yet. When we started with our CLMS service, with the initial operations and then Copernicus 1.0, we were aiming at providing what we call core service multi-purpose data sets that then can be used down the line by, and we were not supposed to touch the downstream sector, because then we will be going into the private offering, as you called it. But more and more we see that users are looking for what is currently called the last mile applications. So I don't have a solution. I know that we have to move more into that direction, but for that we also need more resources within the service, not only to create the data sets, but also to offer more easy to use tools. That's the other colleague called it in the presentation. So we are attentive to that. We have that in mind. I remember that even last week there was a biospace conference about biodiversity and space solutions, and the conclusions were the same. We need to look at users more closely at the users and have more easy to use applications and last mile applications to address. So we are attentive, and we will look into it, and we will build better, easy to use solutions, but we are not there yet.
Okay, thank you. There was one other question I had, which is I'll maybe ask Mattia this one, because I think you've been working in several different areas, because often I think you come to a webinar like this, you see a solution that's been developed for a particular city, but how easy is it to take a solution that's been developed for one particular city and roll it out in a different area of Europe, maybe with a completely different climate, a completely different building structure and so on? How easy do you find it to transfer solutions from one place to another?
Thanks all for the question. Indeed, that was the purpose, to have three different cities in different parts of Europe, also to test this. And let's say, at least for what concerns the purely energy class estimation, I have to say that there's no chance for the transferability, because each and every country, despite we are in Europe, has its own classification. So what is class C in Italy is class D somewhere else, or even E somewhere else. So this is something that is not really known, but for the energy performance classification in Europe, we have each country has its own, and it's not standardized. So this is one point. For the other models, instead, I have to say that the standardization is really possible, because what I had the chance to showcase, especially for what is coming, of course, from the Earth observation part, let's say PV panels in the different countries are still PV panels. So a model that has been developed, for Austria, Italy, equally performs well when you are dealing with Denmark. And the same is if you have let's say, a larger training, also what concerns the shape of the roofs and let's say and the material. But yes, it's something that we really care, because of course it's not negligible, and in some cases, unless you have specific local information, you cannot really overcome some of the major limitations. But I think that with respect to the past, transferability is coming more and more prominent in several projects and more and more doable, I would say, thanks also to the advances in the AI technology.
Okay, thank you. No, that was useful. Coming back to Thomas, actually, there was a question for Thomas in the chat, which I think you've decided that you will take offline and discuss with Daniel bilaterally. But I wanted to generalize it a bit because we have presented several quite similar products here where we have world settlement footprints, we have Urban Atlas, and now we're talking about the global human settlement layer from the JRC. So there are quite a lot of different tools doing different things. Where do you see the pros and cons of each one? What are the differences?
Yes, thanks. Yeah, basically, it was a bit discussed already, or touched at least, this aspect from EA with the services, because what you have to keep in mind is that the JRC with the GHSL is, of course, now even an operational Copernicus service. So there, let's say the primary goal is to provide a standardized frequent data set to the broad user community. And we as DLR are, of course, a large scale research organization. So we are not meant, and we don't want to provide operational services, but our goal is actually to push forward, let's say, the forefront of what is possible. And of course, if you just look at, for instance, the binary data set that I showed, the WSF binary with the GHSL, that's comparable. But what I showed at the end is that our palette is much broader at the moment. So it's still not all published, but our idea is, of course, in a constant cooperation with research, industry, and also planning and the decision makers to identify current data gaps or knowledge gaps, and we then see how and if we can close these with our data sets. So that's why we might not be as operational, of course, as a GHSL service. But on the other hand, for instance, with the 3D, we came up much earlier. That was now kind of picked up. Now, Mattia is actually behind that. We developed an update, let's say, a new data set of the WSF evolution, which we call Tracker, which gives you at a half of 6 months updating basis, a global update of the settlement extent. And this is something that it's much extended, let's say, compared to the GHSL. And this is something that we picked up from the user community. So we try to develop new technologies and push the forefront here. So that's basically the difference. Of course, if you look back or what is, let's say, available, then these products might be identical, but if you look at the current status, there's usually a larger difference. Also, often I have to say in terms of the semantic accuracy, because this is also something where we are constantly work on. Even if it's a binary mask, we don't keep this method, but we constantly try to include new methodologies that came up in order to improve the semantic accuracy.
Okay, thank you. So in the meantime, I see that there's been a question in the chat, but I think this is more one for the 2 commercial companies in the room. And its question is, when you're working with municipalities or local authorities, what level are you working with? Are you talking to operational teams, chief of division, elected officials? Gergely, do you want to take that one first?
Yes, I would like to. So first of all, we usually start the discussion with the elected officials. Then they involve the chiefs of the divisions, because usually they feel the pain points. And then the chiefs ask the team about what they think about the solution or the decision support tool that we are planning to give them. And in the training process and in the implementation process, we always work with the team.
Okay. Mattia, do you want to comment on that, or do you have the same answer?
Well, no, it will be more or less the same answer. So yes, that's the same strategy.
Okay. Okay, that's fine. I don't see any further questions in the chat. So I don't know if anybody else has any last comments that they would like to make. Particularly, I think, Alison, you already made your points quite clearly. So maybe...
If I may, Phil?
Yes.
I jump in.
Certainly, Diego.
Just thanks for I would like to thank all the presenters and the speakers. This was really what we're looking forward. So thanks for that. And I will take the opportunity to ask for a question that will build on the last one, is that for the just not only the private suppliers, but also the public suppliers, when you reach out to municipalities, okay, the point of focal or contact has already been addressed, but mainly, what are the barriers you see in the municipality practitioners to integrate Earth observation solutions or ideas within their workflow or in the chain of making calls?
So who would like to take that one? I think Mattia will take that one first.
No, I mean, it really depends, because there are cities, it depends also on the geographical area, I would say, and cities are more prone to have innovation uptaken. In some cases, one of the barriers is really that the fact that the people in the municipality might not be, say, at the page with the technology. And so they see it as something not really possible, or they you know, it might have not a proper understanding of the current technology. That's where the jargon, that's where really convincing with pure examples, clear example actually plays a crucial role, because otherwise that's difficult. The other case is really the bureaucracy, but I think that we have to face basically everywhere. So that's something that, again, I think that we cannot overcome that.
Anybody else want to elaborate on that? Or?
Yeah, I would like to react on that as well. So it's really depends on the geographical region, and it depends on also about the chief and the leader of the city. Because if someone is motivated and would like to give a change to the city or to the town, to the territory, it can move really forward with the solution. But mainly in Hungary, the main barrier is that the low level of the digitization that we face with. So they say that they already solved the problem somehow. They can do it in the future as well with the same situation. So it's hard to convince them that if they increase the level of digitization, they can increase also many factors in the city, and also about the citizens. They really can add something for the future as well.
Okay. Thank you. No, thank you. That was also useful. I'm afraid we're running a little bit out of time. We have to. We're out of time, but we'll just stay on for a few minutes. We have a couple of final questions. So again, just to get the next steps. One was whether or not you've already used the Earth observation-based services. I can see a few people are already reacting. For those who haven't, there's the QR code, or you can join at menti.com with using the code you see here, 24879070. We'll maybe just leave that one just a few seconds. Possibly we should have had this one at the beginning, but never mind. Perhaps a more interesting question is to move on to the next one, Duke, when you're ready. Which is exactly the point that Diego raised there. What are the opportunities, barriers that would determine whether or not you use these solutions? Is it manpower? Is it cost? Is it technical difficulties? We would very much like to collect your responses to this. I'll just leave this open 1 minute. Because I do think this one is important. Accuracy, yes. Cost, resolution, temporal coverage, everything. Read this. Okay, we can come back to this another time. If you slip forward to the last one, Duke, which is what you would like to see happen next. Somebody has already reacted on this one, training, because we already are creating the catalogue of tools that Diego highlighted. We also have training on available solutions that we are ready to provide. And we also can feed back to the development of new services. Okay, so there the training seems to be, well, way out in front. So I think we will take that on board and come back with a definite proposal on that via the Covenant of Mayors. And then, Duke, if we go forward, finally, I would just like to advertise that we do have one further webinar planned, which is on urban air quality. It will be on the 10th of March at the same time slot. We would be very happy to see you again there. Other than that, I would really like to emphasize that we do want feedback. We would like to get as much feedback as possible. And if we can just put up our contact details, here is the contact details for ESA SEF at evenflow.eu or our website, esa-sef.eu. Please do get in touch. Please contact us. Please let us know your thoughts and what you are missing, what you would like us to do. The more information that we get, the better we'll be able to tune the next steps, such as this training. With that in mind, I'm afraid we're a little bit out of time, but I would like to thank all the participants for joining. I'd like to thank you all for your feedback. I would like to give a particular thanks to our speakers of today. Thank you again. And also to the people behind the scenes who have made this happen. Thank you. And we will hopefully talk again very soon in the next webinar. And I hope to see you all there. Thank you again.
Thank you. Bye.
Thank you. Bye-bye.
Bye.